So what I have here is the electric power assisted steering rack and pinion from a 14th generation Ford F-150. Some of you have seen some of my videos on Open Pilot and Sunny Pilot, 3X for the Ford. I use it in the F-150 and my Mach-E. And there are a few interesting challenges we haven't been able to solve with getting that to work exactly like we want it to. And I feel like I have pushed the limits of what I am willing to test on a street. There's been plenty of times I've gone out at 2 or 3 in the morning to test something because I wanted to make sure the street was empty, just in case things went wrong. But I want to push my testing further to try and overcome the last few challenges we have. And so I bought this off of eBay. It's out of a wrecked truck so that I can see if we can't, get a workaround for some of the issues we're having. And so I've never done absolutely anything like this electronically, trying to reverse engineer something with almost no documentation. So I'm going to try and put some videos up on it for 2 reasons. One, so that if anybody else comes along in the future and is trying something similar, perhaps it provides some useful things to do or not to do for them. But also, if there's anybody out there who has suggestions and tips, this is definitely one of those videos where I'm going to be looking for advice. So if you guys have any, please throw it in the comments. So what we have here is, this is where the steering wheel would connect to, and the steering wheel would turn. And I don't know if I can turn it with my bare hand. I can do it with a wrench. But this is where the steering wheel comes down on a shaft and couples right here. And if you turn the wheel this way, then this rod pushes out. And if you turn it clockwise, that rod right there pushes out. And then those are attached to the tie rods. I've removed the tie rods just to make this more compact so they're not flopping around everywhere. This right here is the electric assist motor. So that is, I haven't ripped this thing apart because I don't mechanically care exactly how it works, but this is a motor. I bet there's a gear here and there's a gear here. And then on the bottom here, we have 3 connectors. Now, when you look at the documentation that Ford provides for this thing, it only shows 2 connectors. These 2 big ones, even though there's a little small one here. So the 2 big ones, on the top, they have 2 big pins. Those are redundant power and ground. So power and ground on the top here, power and ground on the top here, and then on, looks like this one, there's 3 pins on the bottom. That's can high, can low, and 12 volt ignition. So the main power feeds are 40 amp always on, and then the bottom feed is just a 10 amp, letting it know that the ignition is on. The other connector actually comes back to some sort of module that is attached to the steering rack. So what I imagine happens is this module here senses what the driver is doing with the steering wheel and sends that over these wires and into that pin, and then it takes the data from this other module that is sensing what the driver is doing with the steering wheel, combines it with what's coming over canbus for the ADAS, Advanced Driver Assist System canbus signals, and makes a decision on how much torque to apply to the motor in what direction. And so far, all of our efforts with the comma are focused on the canbus data that comes in right here. The issue we run into is that if we send a canbus signal to turn the vehicle around a very sharp curve, when we're done going around the curve and we send either 0 or a signal in the opposite direction, it still doesn't straighten up. It continues to turn. There's something going on inside the logic inside this box where once you've sent it a big signal, it doesn't like to recover from it and start going back towards 0 or the other way. And so I bought this with the intention of injecting canbus signals in here and watching how the rack just moved back and forth while sitting on the floor or on a bench so that I could really test what the canbus signals were capable of. and I'm still definitely going to do that. But I'm also very interested in understanding what this connection from the driver's steering wheel does. Because if you look at some other vehicles, especially the Mazdas, they have what's called a torque interceptor, which basically you would take this from your steering wheel and plug it into the torque interceptor, and then plug the torque interceptor into here in the Mazda equivalent of this layout, and it would be able to tell the power steering control module there that the driver was turning the wheel, even if the driver wasn't, even if it was your open pilot. And the question becomes, why would you want to do that? And the answer is because that would get us around any bugs in the logic that Ford has in the ADAS signals. So I think that's where I'm going to start. I certainly also am going to try and solve this issue using only CAN bus signals, because if you solve the issue using only CAN bus signals, there's no need for an extra box, which is something extra to build or buy to build the torque interceptor. But the torque interceptor is a very interesting concept, especially if there are some Fords that don't support ADAS signals, but still have this style layout where you could install a torque interceptor. But I'm certainly looking for ideas from you guys on how I can go about doing this. Obviously, I can get some power hooked up. Those are just spade connectors. The CAN bus connectors on the bottom there are hard to see, but they're tiny, but I certainly got some Molex or some kind of pins that will go on there. And I can just start injecting CAN bus signals, and that'll be fairly simple. I'm more interested in how to reverse engineer what's going on with this. My initial plan is to put 24 volts on here, and then I assume that, not 24 volts, 12 volts. Sorry, 2 12s is redundant. 12s does not make 24 volts. That's just a brain fart because it's late at night. But I'm assuming if 12 volts comes in here, it has to come out on this plug to power this module. So that was going to be where I was going to start. I was going to put 24 volt, I said it again. 3D printers are 24 volts. I've been doing a lot of 3D printer work too lately. Put 12 volts on there, figure out where it comes in here, and then inject it into there directly so that I can leave this unplugged, and then start probing those wires with a multimeter while I twist that back and forth to see what, if I can see any kind of pattern that makes sense coming out of the multimeter. Hopefully it's just a straight voltage or current, you know, either 4 to 20 milliamps or 0 to 5 volts or something like that for a signal from here to there, and it'll be fairly easy to pick up with a multimeter. If it's some kind of serial communication, it'll be incredibly difficult to pick up with the multimeter. We'll have to somehow get the comma and the panda in line with it. So if you guys have any ideas, please drop them in the comments below. Otherwise, as I make the next steps in the progress on this project, I'll post another video, and maybe that'll stimulate some more conversation.